Welcome all to this webinar on MVIS with Kubernetes. In this section, we are going to learn how easy is it to create an application in Kubernetes cluster. My name is Amir Okde, a cloud enthusiast and working as an architect in Rocket. I'm excited to take you in this journey of MVIS with Kubernetes. For this webinar, I have used following resources. Please feel free to check out as they provide pretty good insights into the world of Kubernetes. The entire source code used during this demo is available at our GitHub repository MVIS Kubernetes. I have used Terminal Emulator, CMDR, but feel free to use any terminal of your choice when you run through the demo samples. For this demo, I have created a simple two-node Kubernetes cluster. We are not getting into the part of setting up a Kubernetes cluster in this demo. Please refer to the resource section for the detailed steps in setting up the cluster. Let's see how we can deploy an application demo Nginx into the cluster. Now we are going to see how to deploy a sample app in the Kubernetes cluster. We have created a project in the GitHub called as Multi-Value University. Under this project, you can see we have MVIS Kubernetes. This repository contains all the samples and documentation required for this demo. We have created under the deployments folder a Hello Nginx, which is our sample application which we are going to deploy in the Kubernetes cluster. The examples MD contains step-by-step instructions how to create the deployment, how to deploy, scale the deployment, and how to delete the deployment. Let me run you through this example on a Kubernetes cluster. The essential step for this one is to clone the repository. So one can use git clone and mvis kubernetes.git is the repository name. So I have cloned the repository. Okay. Let me show you how my cluster looks like. I can run a command called as Cubectl get nodes. This command will display how many master and worker nodes are available in your cluster. I have for this example one master and one worker node. Kubernetes has two concepts of creating an application or deploying an application. One, for a very simplified cases, it's what we call as imperative commands. These are one-line commands where you can create different deployments using just one command line utility. The another one is by specifying a YAML file. These are for much complex cases and definitely for production-based systems. Let me now give you an example how to do this with an imperative command. So I have kubectl create deployment. The name of the image is Nginx. So I want to create an app called demo Nginx, which essentially is an Nginx server. So when I hit on this one, I would be getting a deployment created for it. Our deployment is now created. Let's verify whether our deployment was successful or not. How does one do that? By running another command called as kubectl get deployment. The result of the kubectl get deployment will show whether the deployment was successful or not. So we have a deployment called demo Nginx. The ready displays how many replicas of the application are available to the user. It follows the pattern of ready and desired. So the desired number of replicas was 1 and we have 1 replica ready. The up-to-date column indicates number of replicas that have been updated to achieve the desired state. So it's in our case, again simple, it's 1 replica. The available displays how many replicas of the application are available to users, and that's how it also indicates 1, and the age where it says it's 26 seconds. Now we're going to understand also the pods which have been created by this deployment. One can run kubectl get pods. The result of this command will tell you the name of the pod, their state, and the status and restarts and age. So if you see over here, I have a pod called as demo nginx. So it takes the name of the deployment followed by a random number so that the uniqueness of pods are identified. The ready column says 1/1. It means that it has one container and that container is running. So if you have two containers, it will be saying 2/2 or depending on the state of the container. The status indicates whether it is running or not. In case of failures, it will say crash or image whatever pullback errors. Restarts. As you see, a pod can go multiple restarts in case of failure. So in this case, this restart column will indicate how many restarts a pod had. This is an useful indicator to identify whether our cluster and our application is stable or not. If there are multiple restarts, kind of indication should be useful for us to understand what is happening with our pod. I want to show you a very handy command wherein one can understand whether our application, the Nginx, is up and running. So Kubernetes has provided us a command called as kubectl port forward. What it does, it forwards the name of the pod. We have to give the name of the pod and the port in this case. So it is 8080. That is the port which it will forward the Nginx traffic from the 80 port. So 80 is the port defined by default of the demo Nginx app, and we are going to forward it to the 8080 port on our local system. And copy the demo Nginx pod name. I just replace the pod name over here with the pod which we have been now deployed in the cluster. And this will start forwarding the traffic from the Nginx port 80 in the cluster on our machine where we are running the kubectl command at 8080 port. So let's see now whether this port application is accessible at 8080 port. So I have localhost 8080 and we see the Nginx welcome page. This indicates that our pod is up and running and we have successfully deployed our sample application into the Kubernetes cluster. So with this example, one can see that one can debug or see whether the pods are up and running. The pods can be anywhere in an AWS cluster or any other Kubernetes cluster. With a simple port forward command, one can see how this application is up and running. That's the benefit of having a kubectl port forward command. Now we would be running to an example where we want to scale the application. The use case of scaling an application is as follows. When the load on the system, when the number of users, let's say, want to reach to the Nginx application are increasing, we want to scale our application. Again, this can be done by a simple imperative command, kubectl scale deployment. The replicas, so I want to increase the replicas to 2. So it means that I want to have 2 pods for my application. So if I run this thing, the deployment will be scaled with number of pods to the number 2. How does one verify that? It's simple. One needs to run kubectl get pods. The result of this command will let you know that now we have 2 pods, demo nginx ending with 9s frw and another running with kk8. In this simple way, we can scale our deployment using a simple command line utility called Cubectl scale deployment. In this way, we are able to show you how we can deploy a simple application into the Kubernetes and scaled application. So let's clean up our deployment, which we have created in this cluster. So I can run kubectl delete deployment demo nginx. The result of this command would delete the demo nginx deployment followed by deletion of the replica set and the pod. This is been done by the Kubernetes server automatically. I can verify whether the deployment has been successfully cleaned or not. Let me run kubectl get deployments. Oh, I missed B over here, and the result of this command should show you that there are no deployments.
Here are some of the other MBU courses which I would highly recommend to check out. MBIs with Kubernetes, Containerization and Orchestration. In this, we would understand what is the need of orchestration and benefits of it. MVIs with Kubernetes, setting up and deploying sample app. In this, we would be experiencing how to deploy a sample app into the Kubernetes. MVIs with Kubernetes, setting up MVIs with Redis server. Here, one would deploy MVIs in Kubernetes along with the Redis server and in-memory data store. MVIs and containers. How easy it is to run MVIs as Docker container. And finally, MVIs in prominent cloud providers like Amazon AWS and Microsoft Azure.